Yeah, I was wrong. But I got my haircut at Midtown, so check out the barber store there. It's pretty solid. Uh, okay, here's my challenge for you, and we're just going to see how it goes. I'm going to give you guys like 3 to 5 minutes to get started with it, and then we'll come back together to talk about it because I'm going to give you a problem to do. This is 4.6, just so you know. I don't know why I just started with an example. 4.6. Let me clear that out of the way. Our focus today is graphing with calc. And just to be clear, because it could be misleading, this does not mean graphing with a calculator. It means using the tools of calculus to help us graph better and faster than we probably could with a, I don't know if it's true that we could do it faster than with a oh my gosh, I just said it's not this. Boom! Graphing with calc, not calculator. Goodness gracious. All right, so just so you guys know, I'm going to leave room here in case we need it. If it winds up just being blank in your notes, that's okay. I have a wonderful 7-step process that I typically suggest. So if you want to know what we may very probably fill in, there's 7 things that I have written here. Whether it actually has to be 7 or not, I don't know. I think I just worked it into this nice because I like the number 7. But underneath all this, all we're doing is we're just going to put everything together. And I know we did one of these before the break. I know we did. But I just want to see what you guys come up with. I want you, for the next couple minutes, to sketch the following function using our wonderful calculus stuff. So our first one, let's graph, without using our calculators ever, 2x cubed minus 3x squared minus 12x. And you've done problems like this in Algebra 2. You certainly graphed some of these, and you got a pretty good sketch, or you copied your calculator, depending on how you actually did it in Algebra 2. In pre-calc last year, we did it like this, where we found the roots, we found the multiplicities, we found M behavior with the math dance, and we did it. But now we're getting better pictures, because we're actually going to be able to find where our extrema live here. I'm going to give you guys the next 5 minutes, and we'll let old Gravity Cube do this. Have I showed you guys this? Gosh, I love it. Okay, 5 minutes. I want you guys to try to sketch this using calculus. Look back at the example. We'll have to come together, I'm sure. If you're looking at that and going, I don't know what the hell to do. Looks like I got 5 minutes of free time. Don't ask me questions. I'll come around, but we will talk as a whole class. You guys should pull air into your lungs and then exhale it while changing the shape of your throat and mouth to communicate ideas with one another to be able to help. Cool. I will give you a couple of, actually 5 minutes. Trouble looking through this. I think that it'd probably be helpful because there's some calc and some algebra. I don't know why I took my mask off that we should be doing here. Looking at this, should we give ourselves these nice steps first so we have kind of a roadmap to follow? Now, for the record, these aren't really sequential. There's no real particular order that these have to happen in, other than the fact that I think it's reasonable that you would find the first derivative before you find the second. But I'm just going to present them in the order that I typically think about it. Kalisha, don't be mad, but maybe we're going to do something that you asked about first, but I suggested let's do the calc first. So like we'll see. Your idea was not bad. It's just not where I would start, despite what you're about to see, just so you know. Okay, so right off the bat, if you want to be able to sketch a function, what's one thing you probably need? Like what are some important parts of a function that we might care about? Where it's x what? There's one more word that you're looking for. X in intercept. I'm just going to say let's find all the intercepts. Now, for these, this includes both the y and the x-intercepts. Okay. Now, we'll do that here in a second. We're just going to get this whole list defined. Once we've done this, and this function won't have any, but there are functions that exist out there where they have these vertical and horizontal bars that we never touch, right? And what are those called? What if you say it wrong? Asymptotes, yeah. So check it out. For part 2, I would just say let's find, and I'm just going to call vertical asymptotes, horizontal asymptotes, and I don't think we've had to use this year, but EB. Does anybody recall what EB? End behavior, right? It's that math dance that we're looking at. Okay, so we want to know how does our function end and all that good stuff. Once we're here, this is all the algebra that we did last year. Like from this, we can get a pretty decent graph of it. But then we're going to jump to calc. we're going to find y prime, or f prime in this case. And I'm just going to say d dx so that we don't worry about the letter of it. And what do we get from f prime? Angel, I heard you say it. When we find the derivative and we find the zeros of the derivative, those are called something. Critical numbers. Or critical values. I don't remember which one. I think it bounced back and forth between them. Crit numbers is how I write it. Okay, once we have this, and these you could kind of have in the same step, what's the whole point of the critical numbers? Like f prime tells me where my function does something. If f prime is positive, what does it mean for me? It's increasing, right? What does it mean if f prime is negative? So when we look at these, your book, just so you guys know, if you use your textbook as a resource, they do a big table of stuff. I don't typically make a big table. How do we make sense of what's going on particular intervals? Number line. So we'll just say number line for increase and decrease. Now, this is like really shortened, right? We're using a number line to find the intervals for which my function increases and decreases, but I don't really want to write that long of a sentence here. Okay, so we find f prime, we find where it does this, right? What's next? So points of inflection or possible points of inflection, but what do I have to use? D squared, dx squared, the second derivative. And possible points of inflection, or popoi, if you will. Okay, once we have our lovely possible points of inflection, what's next? What do we do with those points of inflection? So where do we put them to decide our concavity? But you're on the right track for sure. Yeah, put these on a number line. Number line and our intervals of concavity. And then finally, once we have all of this, and it seems like a lot, and it is kind of a lot, but I really hope that you'll agree that it is much nicer than spending like 30 minutes just finding points to plot. Once we have all this, we just graph it. Now, there is one more idea hiding in here that I'm going to introduce after this one, but we're going to see we can get around without it, but it's not terrible to deal with. All right, so we have all of this, and in no particular order do these need to happen. I've already given us the first and second derivatives. That is going to allow us to knock out 3, 4, 5, and 6. Pretty straightforward. Should we knock these out first, or do you just want to come back and get these at the end, the steps 1 and 2? How is your work organized? Do you have the zeros right away, or did you start with the derivatives? So let's do the derivatives since we already have them, so we don't have to readjust our page and everything. Abigail, you started with the roots. Keep it. That's fine with me. As long as we have all the same work, the order isn't really super important. Okay, so here is f prime. I need to find the critical numbers, and I get those by setting this equal to what? So 0. So let's do that. I'm going to do 0 here, and anything immediate that you can see I can do with this trinomial. I'm going to factor out the 6. I'm going to simplify, is what JJ said, divide by 6. I'm cool with it. And you might just divide both sides by 6. I'm going to factor it out right now just so it's really clear what happened. X squared minus x minus 2. Okay. And now, just to make things nice, I am going to use Leanne's advice. Let's just divide by 6 so that we can simplify this problem. Okay. So I'm just pretending like that's gone in my head. Anybody think of factors, or better than that, how do I factor this? I'm going to use a shortcut. I'm looking for factors of -2 that add up to what? 2 numbers that multiply to be -2 and add up to -1. Do those exist? Yeah, it's -2 times 1. That will do the trick. So as soon as I find those, how can I write this in its factored form? Good. X minus 2 and x plus 1. What did we just find? We found our critical numbers. Where are they? At -1 and 2. the zeros of my derivative. Now, I don't recall when we put these on a number line, you guys will have to help me remember if we're using one number line or if we're using a bunch of them. I just don't remember how we did it. But let's jump over to the second derivative here real quick. Okay, we do the same thing here. Can I go a little bit faster through this one? We don't need to talk about the factoring here. Okay, I'm going to take out the GCF, right? So 6 and 2x minus 1. I think that my papoi is simply going to be what? 1/2. Okay, everybody's still on board with these. Now, from just this information, we can do our number line and we can get a ton of sense made of this graph. Is there any part of this that I've lost you or lost a part of anything that we've lost in this? Okay, before I just put these on a number line, because I want to have, I'm going to have, do we use 3 number lines before? I'm going to have one for f, I'm going to have one for f prime, and I'm going to have one for f double prime, and I'm just going to layer them on top of each other so that they're on the exact same scale. So let's do the other groundwork. If I want to find the intercepts, and this is weird that we're going out of order, but again, as long as you do it all, I don't really care the order. Okay, let's find some intercepts here, and let's see, intercepts feel green to me. If I want to find the zeros, the roots, the x-intercepts, it's by setting f of x, the original, equal to what? How do you find the zeros of a function? Yeah, there we go. So set it equal to 0. So let's see that. We have 0 equals, before I just write this blindly, is there a common factor already that I can take out? X. Let's take out an x. Leaves behind x squared minus 3x minus 12. Now, I'm partially factored at this point. Riley, does this give me a root already? Good. So I'm just going to comment here, the roots. The first one is at x equals 0. Can anybody in here tell me 2 factors that multiply to negative 12 and add to negative 3? Me neither, just so you know. It's ugly, right? If we had to do it by hand, Abigail asked, can I use my calculator? Yo. Do I have a typo? Oh, did I write something wrong? Thank you for the catch. I didn't even see it. Let me look back up. Here's my original. It should be 2x squared. Thank you. Can anybody find factors of negative 24, rather, that add up to negative 12? And just to be very clear, I had a typo. This 2 was not there. It should be, because I just factored the x out. Yep, that's my bad. Good catch. Okay, I can't either. But here's the good news. If we had to do it by hand, could we? How would you find the zeros of this quadratic? Negative b plus or minus. Did we sing it last year when we did it? Okay, so you can also do it to Pop Goes the Weasel if you guys didn't know that. I'm really going to lean into the sing-songy stuff. Maybe we talked earlier about the musical about this, right? So maybe I'll allegorically continue working on this musical to make sure that we can get a nice way to memorize everything. Negative b plus or minus the square root of b squared minus 4ac all over 2a. If you know the song Pop Goes the Weasel, that's a quadratic formula. I don't do that. In my head, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. That's how I remember it. Can you guys quadratic formula? Everybody in here confident in your ability to quadratic formula? Okay, I'm just going to save us some time. Quadratic formula. It gives me, and I'm going to give us really ugly approximations eventually. You want decimals? Good. 3.312 and negative 1.812. Negative 1.812. Abigail, can you confirm those? Okay. We're going to trust that it's okay and that my work was good when I did this problem. We should probably verify. You guys do me a favor real quick, just because I don't want to get through this whole thing and realize I'm wrong. If I want to solve this this cubic on my calculator, how do we do it? F2, we're going to solve. You're going to type this in, and you're going to set it equal to what? Equals 0, and then how do you tell it what to solve for? comma, x. I'm going to give you guys a second. Once you have it set up, hit diamond enter. So it'll give you an approximation. JJ, I'm going to grab you an 89. And you're going to use this F2 to solve. And I'll give you guys a second. I just want to confirm that my numbers are good. All right. So at this point, I have the intercept, the x-intercepts at least. Can I get the y-intercept pretty easily? How do you get the y-intercept of a function? So yeah, just evaluate f of 0. And it's 0. Okay, easy. And I just did 2 times 0, minus 0, minus 0. And it's 0. Okay, so we have all of this information in front of us now. And please confirm, this isn't the easiest thing you've ever done, but is this easier than making 50 points on a table? Like, there's still value in this. I hope you agree. Okay, so we're going to take all of this information, and I'm going to slide to the right just so I can try to make it all make sense. I'm going to start using number lines, and we're going to try to organize everything. And we'll sneak in one idea here at the end. I don't know that I'm going to give you homework tonight. We'll see. There's not a whole lot to do other than just let's practice this, but we keep practicing it. Okay, are we doing multiple number lines or just one? Multiples? Okay, so let's see. Green, I'm just going to do them in order here. Green is what I used for my f of x. So here's f. And let's see, blue is what I used for f prime. So I'm going to do the same to scale right underneath of it. We'll call this f prime. And then we'll do orange for f double prime. All right. So we're just going to start adding stuff to these. If you would like to use a table instead, I can show you what the table looks like, but I think this is nicer. Okay, what numbers go on my green number line? For f. So do I have a typo or do you have a typo? Is this -3 or +3? I have a typo? So it should be +3? Okay, so we're going to put -1.812. And I'll do it green. And remember, only these numbers on your number line. -1.812. What's the next number? 0. And the next one? 3.312. And I'm not going to do it perfectly to scale, but what I just did, and you guys couldn't see it, I mean, you might have been able to see if you were paying really careful attention, but what I did when I was trying to decide where to place these is I glanced over here to see what other numbers go on my number line, so I know that if I needed 3 to be here, if I had something way out here, that I could still see it. Okay, this is the biggest value that's going to go on any of these number lines, so I know that that one can be really far right. -1.812 is the smallest value that's going to go on them. I'm pretty comfortable that I'm going to be able to see all my critical values or possible points of inflection in this scale. All right, so let's just check something here. I'm going to plug in, pick something in one of these intervals, and we'll see just, it's going to give us some info. And let me rephrase that because that's really broad. We found 3 roots, and they each showed up 1 time. All I need to do, I'm going to use multiplicity because I know what the graph is going to do. I just need to know if it's positive or negative on any of these intervals. So I don't care if you pick a really negative, a -1, a 1, a 2, a 3, or a really big positive. I just need to check one of them. Give me any number that's not exactly these. 1. Okay, if I plug in 1, let's just check. It's 2 times 1 is 2, minus 3 is -1, minus 12. That's going to be a negative. I'm plugging it into f, and I'll even say f of 1 right here is less than 0. I now know that my function is negative here. I'm going to double check another one. Nope, I'm cool with that. Somebody second that without distrusting my math. 2 minus 3 minus 12 is negative. Okay, why do I only need to check one of them? So what is it here? It's positive. And what does this really mean? It means my graph is what? Above the x-axis. It doesn't mean if it's increasing or decreasing, it just means it's above. Here it's positive, and here it's negative. Remember, if it shows up an odd number of times, it switches signs. Okay, So we have all of this, and I'm just going to do a quick confirm real quick. That was redundant. Can you guys show me a math dance move that you would bust out at a wedding if you were feeling real positive and a little bit odd? Notice a positive leading coefficient and an odd exponent. How would you dance if you were positively odd? I can't tell if you guys don't really understand that I'm trying to be silly as I'm speaking this and addressing the math stuff. If you're at a wedding, are you feeling positive generally? Any of you guys ever feel kind of weird sometimes? You're humans. I imagine you all feel weird from time to time. Gosh, positive and odd. What's a positive x look like on a graph? That's it. Yeah. Up to the right, down to the left. Does this go down to the left and up to the right? Okay, so I've just confirmed my M behavior without ever having to actually write down the M behavior. Awesome. F prime, who, there's that allegorical language again, who goes on my number line here? -1 and 2, and I'm going to try to draw it at least kind of to scale. Here's roughly -1, and 2 is like over here. Now the good news is that those were both roots that showed up an odd number of times, so once again we can employ this idea of multiplicity. Miss Arcega, I want any value in here that's not -1 or 2. If you pick the, good. Say it louder and prouder. 0! Let's do f prime of 0. F prime of 0 is what? Positive or negative is all I have to worry about. Negative. And it's positive here and positive here. Now, if you want to do this, you can. It's not necessary. Positive just means that I'm increasing, decreasing, and increasing again. What did we just identify? Slopes for sure, but if you think of a graph, and here's me being a graph, I'm going to go up and then down like it happened right here, right? What did you find right up here? We just found an extrema. So that's really what's happening. You're right, just so you know, it is intervals of increase and decrease, but we see that there's a maximum right here, and there's a minimum at x equals 2. All right, f double prime, who goes on here? One more time. Possible points of inflection, what's the only number that goes here? 1/2. So again, just at least kind of to scale, 1/2. I'm going to check f double prime of 0. That's the easy one to evaluate here. And f double prime of 0 is positive or negative? Negative. And positive. What do these mean? So, kind of, the second derivative would. What does the fact that f double prime is negative mean about f, rather? This is concave what right here? Concave down, which is like a sad parabola, and this is concave up. Okay. With all of this information and a little bit of, we can pick out some nice easy points so we get some really handy ones with, you think we can graph this? Now, I'm just going to try to summarize everything. Your assignment, quote unquote, is going to be to try to put all this together on a graph for me. That's what I want you to do. But let's make sure that we leave ourselves with a solid place to jump in. If I wanted a really good graph, I know that this is where a local extrema occurs. It's a maximum. I know what happens when x is -1. Do I know the value that it happens at, though? Like, it could be at -1, 2, but it could also be at -1, 500, right? And those are very different values. For just a brief moment, we should use our calculators to get a couple of nice points that'll help us get this graph as nice as it can possibly be. I care where the extrema would happen. So let's get some nice points to put on our graph. And I'm just going to indicate these. We'll use white. We'll just say some specific points that we want to include. Now, I'm going to write more than we have right here. Right off the bat, I know that I'm going to have the point -1.812, 0. And I'm going to have the point 0, 0. And I'm going to have the point 3.312 and 0. What are all these three numbers? Where did I get these? These are the roots that we found on that green number line for f. Okay, max. Where do I have a maximum? It's at which x value? -1. And then I'm going to write this uglier than you might now. I'm going to say it's at -1, f of -1. Now, this is doable. It's not awful. F of x, I'm going to have to scroll up so I can see it. Oh, it's right here. What's f of -1 going to give me? So that's -2 minus 3 is -5 plus 12. I think that's 7. F of -1 should be 7. I'm pretty sure that's true. Here's f. -2 minus 3 is -5 plus 12. Yep, it's 7. Okay, any other nice points that I should have? I have a max at -1, 7. Where's my min? At 2, and do me a favor, I want you guys to find me f of 2. Love what you're doing, Abigail. Everybody else, love what you're doing as well, because I can see the gears turning in your head. I think it's -20. Okay, any other important points that we should plug in and find? Do I have a POI? Ms. Bacalzo, I saw you nodding yes. Where would you find that point of inflection? 1/2, comma, f of 1/2. And Abigail, because I think you're using your calculator to do this, you have it saved as y1, or are you just typing in the numbers? Okay. I don't know if I have it written down or not. F of 1/2 is the goal right now, which I don't really want to do all that. What do you get, Abigail? -6.5? Are we going to trust her? Okay. Cool. I want you to take all of this information this evening, these 3 number lines, and these 1, 2, 3, 4, 5, 6 points. I want you to give me a graph of this. And tomorrow at the start of class, I'm going to take a few random of your graphs, and I'm going to put them up here and compare them to the one that we make on Desmos. Cool. All right. That is your assignment. Peace out.